And now in this lecture we'll find out the value of x. In the drawing we have a quarter circle. FAE is a quarter circle. Inside this quarter circle we have this square ABCD. In addition, we know that this is angle GDC is equals to theta. Angle EDC equals to theta. Line segment DE equals to 12 units in its length. And our mission is to find out the length of this line segment DG that is equal to x. So first of all, we know that ABCD is a square, and we know that all the angles inside a square are right angles. So this angle is a right angle inside square ABCD. This angle is also a right angle. This angle is a right angle. And finally, this angle is also a right angle. So, what is the size of angle ADE? What is the size of this angle? The size of angle ADE equals to the size of the big angle ADC, that is 90 degrees, minus theta. Again, 90 degrees, the size of the big angle that is 90 degrees, minus this angle that is theta, is equals to the missing angle ADE. So actually found out that angle ADE equals to 90 degrees minus theta in its size. In the next step, we will extend line segment GD and line segment EA by straight line until they touch each other. And then define the touching point of the extended line segment GD with the extended line segment EA as H. We'll extend side CD of the square by straight line. We define this point as F. So those two angles, they are defined as vertex angles and they are equal to each other. But this angle equals to theta, therefore this angle must be also equal to theta. So what is the size of angle ADF or FDA? If you focus, we know that CD is one side of the square ABCD, therefore it is absolutely a straight line. Then we extended the straight line CD by straight line, and the result is CF. When you extend the straight line by straight line, the result must be a straight line. So CF is a straight line. So if you focus on the lower side of this straight line CF at point D, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of CF at point D? We have this angle that is a right angle, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the lower side of CF at point D to 180 degrees, this missing angle must be equal to 90 degrees in its size. So what is the size of the missing angle ADH? What is the size of this angle? Angle ADH must be equal to the big angle FDA, that is equal to 90 degrees minus theta. Again, angle FDA that is 90 degrees minus theta will be equal to the missing angle HDA. Therefore, the missing angle HDA equals to 90 degrees minus theta in its size. We'll focus, we know that AB is one side of the square, therefore it is absolutely a straight line. And we extended the straight line AB by a straight line, therefore the result is a straight line. So BH is also a straight line. So if we focus on the upper side of the straight line BH at point A, here the sum of the angles must be equal to 180 degrees according to the rule that I already mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of BH at point A? We have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. So in the next step, we will prove that the right triangle ADH is congruent to the right triangle ADE. We'll prove that those two right triangles congruent to each other. So I write it down. We'll prove that this right triangle ADH is congruent to this right triangle ADE. I repeat again. We will prove that those two right triangles can go into each other. So why those two right triangles can go into each other? First of all, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle ADH in the right triangle ADH. And it is equal to this angle, it is actual angle ADE. In the right triangle ADE. So repeat again. Angle ADH in the right triangle ADH equals to angle ADE in the right triangle ADE. They are both equal to 90 degrees. Again, angle ADH in the right triangle ADH equals to angle ADE in the right triangle ADE. They are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, this is side DA. Side DA is a common side that belongs to both triangles, so we can write down that DA equals to itself. It's a common side that belongs to both triangles. Okay, again, side DA equals to itself. It's a common side that belongs to both triangles. And finally, those two angles are both right angles, therefore they are equal to each other. So actually, this is angle HAD in the right triangle ADH, and it is equal to this angle. It is actually angle EAD in the right triangle ADE. So I repeat again. Angle HAD in the right triangle ADH equals to angle EAD in the right triangle ADE. They are both equal to 90 degrees, therefore they are equal to each other. So we actually proved that the right triangle ADH is congruent. This is the sign of congruent to the right triangle ADE according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove the two angles and the side that included between the two angles in one triangle are correspondingly equal to two angles and the side that included between the two angles in a second triangle, then you actually proved that the two triangles are congruent to each other according to angle side angle rule. And here we proved that those two angles and the side that included between those two angles, that is side DA in the right triangle AHD, are correspondingly equal to those two angles and the side that included between those two angles, that is the same side DA in the right triangle ADE. Therefore we proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side DE in the right triangle ADE is equal to side DH in the right triangle ADH. Repeat again, we derive that DE equals to DH according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say DE and DH, must be also equal to each other. But DE equals to 12 units according to what is given as the equation. So we can write here that DE equals to 12. And from this equation, 12 equals to DE equals to DH, we will derive that DH also equals to 12 units in its length. So this is side DH and it is equals to 12 units in its length. Likewise, from the fact that those two right triangles can go into each other, we will derive the side AE in the right triangle ADE is equal to side AH in the right triangle ADH. Okay. AE equals to AH according to the sum rule that corresponding angles in congruent and corresponding sides in congruent triangles are equal to each other. But what is the definition of line segment AE? Line segment AE is the radius of this quarter circle. So we'll define the radius of this quarter circle as R, and therefore AE equals to R. So we can write here that AE equals to R according to our definition. And from this equation, R equals to AE equals to AH, we will derive that AH is also equals to R. AH equals to R. Okay. So in the next step, we join points G and E together by a straight line. This is point G. This is point E. So we join points G and E together by a straight line. By joining points G and E, we created triangle AGE, and we join point G and A together by a straight line. So during this construction, we created triangle AGE, and here we have point A, point A is the circumcenter of triangle HGE. Again, point A is the circumcenter of triangle HGE. So I write it down. Point A is defined as a circumcenter of triangle GHE. And here, what is the definition of line segment AG? Point A is the center of the quarter circle, and point G is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of the quarter circle that according to our definition is equals to R. So here, AG equals to R. Repeat again that point A is the circumcenter of triangle AGE. So what is the circumcenter? It means that point A is located in the same distance from the three vertices of this triangle HGE. The three vertices are H, G, and E. Why? Because the distance between point A and the vertex H is R, and the distance between point A and the vertex G is also R, and finally the distance between point A and the vertex E of the triangle AGE is also R. Okay, for that reason, point A is defined as the circumcenter of triangle GHE. In addition, and because of the fact that point A is the circumcenter of triangle HGE, point A is also defined as the center of the circle that blocks triangle HGE. So I write it down. Point A is also defined as the center of the circle that blocks triangle GHE. But we know that any circle that blocks triangle must pass through their vertices. Therefore, the circle that blocks triangle HGE must pass through the three vertices of triangle HGE that are H, G, and E. Okay, so we have a circle that blocks triangle HGE, and it passes through points H, G, and E, and its center is located here at point A. And what is the radius of the circle that blocks triangle HGE? We know that the center of the circle that blocks triangle HGE is located here at point A. And you also know that the circle that blocks triangle HGE must pass through the three vertices that are H, G, and E. So the center is at point A, and the circle passes through point E. So what is the definition of line segment AE? It starts from the center of the circle, that is to say from point A, and ends at point E, that is the point of the circle itself. We know that the circle that blocks triangle HGE must pass through point E because it is one of the vertices of triangle HGE. And therefore, AE is the radius of the circle that blocks triangle HGE. And we know that AE equals to R. So in conclusion, you can say that the circle that blocks triangle HGE passes through point H, G, and E. The center of the circle is here at point A, and the radius of the circle is R from one side. But from the other side, if we complete this quarter circle to a circle, then the center of the circle will be here at point A, exactly as the center of the circle that blocks triangle GE, and this radius is R, because the radius of the quarter circle is R, therefore the radius of the circle must be also R. So the center of the circle that blocks triangle HGE is also at point A, and its radius is R. And the center of the circle that will be created by completing this quarter circle to a circle is also at point A, and its radius is also R. So we have two circles with the same center that is A and the same radius that is R. And therefore the two circles are not two circles but one circle. Why? Because if you have two circles with the same center and the same radii, then it is one circle that is A, that has the center is the circle is A and the radius is R. And therefore we can conclude from all the things that I said here that the circle that will be created by completing this quarter circle to a circle must also blocks a triangle HGE, because they are the same circle. The circle that will be created by completing this quarter circle to a circle must also blocks triangle HGE, because it is the same circle. And because of the fact that the circle that will be if we complete this quarter circle, if we complete this quarter circle to a circle, we will get a circle that passes through point H. So I will draw the circle that will be created by completing this quarter circle to a circle. And we know that it must pass through point H. Okay? But again, that the circle that I created by completing this quarter circle to a circle must pass through point H. Okay? So what is angle edge AE? Angle edge AE, this angle equals to 180 degrees. Any angle that is equal to 180 degrees is defined as a straight line. Therefore, edge AE is a straight line. It is a straight line that touches the circle at 2 points, point E and point H. Any straight line that touches the circle at 2 points is defined as a chord. So edge AE is a chord, but it is a chord that passes through point A, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. In conclusion, I shall find out that edge AE is the diameter of the circle. Again, edge AE is the diameter of the circle, or edge E is the diameter of the circle. Again, edge E is the diameter of the circle. And we have angle, peripheral angle edge GE is subtended on edge E, that is the diameter of the circle. And we know that any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees. Therefore, peripheral angle edge GE is equal to 90 degrees in size. So in quadrilateral ADGE, inside this quadrilateral ADGE, those two angles, those two opposite angles, they are both right angles, and the sum of two right angles is 180 degrees. So inside quadrilateral ADGE, we have two opposite angles that the sum of them is equal to 180 degrees. And any quadrilateral that has two opposite angles that the sum of them is equal to 180 degrees, it's a cyclic quadrilateral. That is to say, it can be blocked by a circle. So this quadrilateral can be blocked by a circle. Therefore, I will draw the circle that blocks this quadrilateral. So the red circle is the circle that blocks quadrilateral ADGE. Now we can implement in our drawing rule 12. I repeat quickly on rule 12. Rule 12 is true in any circle. So in any circle, if we have the common external point P, and we have chord AB, the extended chord AB touches the common external point P here, and the extended chord CD also touches the common external point P. So in this drawing, the following equation will be true: that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule 12 in our drawing. Why? Because in our drawing, we have this red circle. Inside this red circle, we have the extended chord EA touches the common external point H, and we have the extended chord GD that is also touches the common external point H. So all the requirements of rule 12 are satisfied, and therefore we can implement rule 12. According to rule 12, the following equation is true: that GD times GH equals to, again, that HD times HG equals to HA times HE. Again, HD times HG equals to HA times HE. So I write it down: HD times HG is equal to HA times HE. Repeat again. In our drawing, the following equation will be true according to rule 12. That HD times HG equals to HA times HE. Repeat again. HD times HG equals to HA times HE. HD is 12 times HG. HG in total equals to 12 plus X, because HD is 12 and DG is X. So in total HG equals to 12 plus X. Again, HD is 12 and HG is 12 plus X, and it is equals to HA times HE. HA, here HA equals to R, and HE is the diameter of the circle. That is equals, of course, to 2r. So AG equals to 2r. So in conclusion, actually, according to rule 12, we found out that 12 times 12 plus x equals to r times 2r. Here we divide this equation 1 by 2, and you get that according to equation 1, 12 over 2 is 6, so 6 times 12 plus x equals to r times 2r is 2r squared, and 2r squared over 2 is r squared. Here we'll divide this equation 1 by 6, and we get that according to equation 1, 12 plus x equals to r squared over 6. Here we subtract 12 from this equation 1, and finally we get that according to equation 1, x equals to r squared over 6 minus 12. Okay, again, according to equation 1, we found out that x equals to r squared over 6 minus 12. I remind you that x is the variable that we are looking for in this question. In the next step, I will copy the right triangle ADE, this right triangle ADE in a new page, and we will implement on this right triangle ADE the Pythagoras theorem. But before that, we will define one side of square ABCD as y. So AB equals to y, CB equals to y, DC also equals to y, and finally side AD also equals to y. So copy the right triangle ADE in a new page, and we'll implement on it the Pythagoras theorem. So according to our definition, side AD equals to y, and what is the length of side AE? We already found out that A equals to R, it is the radius of the circle. And finally, the hypotenuse DE of the right triangle ADE equals to 12 units in its length according to what is given as the question. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle ADE that I copied from the original drawing. This right triangle ADE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. This will be equation 2. The hypotenuse on this right triangle is DE, therefore the square of the hypotenuse is DE squared. And it must be equal to AD squared plus AE squared. So according to the Pythagoras theorem in the right triangle ADE, we found out that DE squared equals to AD squared plus AE squared. DE equals to 12, therefore DE squared is 12 squared, that is 144, and it is equals to AD squared. AD is y, therefore AD squared is y squared plus AE squared. AE is r, therefore AE squared is r squared. So in conclusion, I should found out that according to equation 2, y squared plus r squared equals to 144. In the next step, we join points A and C together by a straight line. By joining points A and C, we actually created the right triangle ABC. So in the next step, I will copy the right triangle ABC in the new page, and we will implement on this right triangle ABC the Pythagoras theorem. Again, by PT here is the abbreviation for Pythagoras theorem. The hypotenuse AC of the right triangle ABC is actually the diameter of the circle. Why? It is actually the radius of the circle. Why? Because it starts from point A, that is the center of the circle, and ends at point C, that is the point on the circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of the circle, that is equal to R. According to our definition, AB equals to Y, and BC also equals to Y. So actually, this is the right triangle ABC that comes from the original drawing. According to the Pythagoras theorem, in this right triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ABC is AC, therefore the square of the hypotenuse is AC square. And AC square must be equal to AB square plus BC square. AC equals to R, therefore AC square is R square, and it is equals to AB square. AB is Y, therefore AB square is Y square, plus BC. BC is also Y, therefore BC square is Y square. So in conclusion, we actually found out that according to equation 3, R square equals to Y square plus Y square, that is 2Y square. Here we divide this equation 3 by 2, and finally we get that according to equation 3, Y square equals to R square over 2. This is according to equation 3, but we've already found out that according to equation 2, Y square plus R square equals to 144. This is according to equation 2. Now we can substitute Y square in this equation 2, by R square over 2 from this equation 3. We'll do it now, and we get that according to equation 2, Y square is R square over 2 plus R square equals to 144. So here we'll multiply R square by 2, and then we'll divide it by 2 in order to have a common factor with R square over 2. So in the numerator we'll have in total R square plus 2 times R square divided by 2. This is equals to 144. Here we'll multiply this equation 2 by 2. And finally we get that according to equation 2, we have here R square plus 2R square is 3R square. This equals to 2 times 144, that is 288. Here we divide this equation 2 by 3. And finally we get that R square equals to 288 over 3, that is 96. So in conclusion, we actually found out that according to equation 2, r squared equals to 96. But according to equation 1, we've already found out that x equals to r squared over 6 minus 12. Now we can substitute r squared in this equation 1 by 96 from equation 2. We'll do it now, and we'll get that x equals to r squared, that is 96 over 6 minus 12. And 96 over 6 is 16, and 16 minus 12 is 4. So in conclusion, we found out that x equals to 4 units. So actually, x, that is the length of line segment DG, is equals to 4 units. Okay. Repeat again. The length of this line segment DG is equal to x is equal to 4 units. So in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment DG is equal to x. We found out the value of x. So in the domain we have a quarter circle. FAE is a quarter circle. Inside this quarter circle we have this square ABCD. In addition, we know that line segment DE equals to 12 units in its length. This is angle GDC, this is equal to theta, and this is angle CDE, this is also equals to theta. Again, our mission is to find out the length of this line segment GD, that is equal to x. We have to find out the value of x. So, in the first step, we know that ABCD is a square, and we know that all the 4 angles inside this square must be a right angle, so those 4 angles are all right angles. And here we have, so this is a right angle, and this is angle theta. Therefore, the missing angle must be equal to 90 degrees minus theta. So angle AD equals to the big angle that is 90 degrees minus theta. So this missing angle ADE, equals to 90 degrees minus theta. And then we extended line segment GD and line segment EA by straight line until they touch each other. They touch each other here at this point. We define their touching point as H. And here we extended the side CD of square ABCD by straight line. This way we got the straight line CF. And here we have 2 vertex angles that must be equal to each other according to the rule that vertex angles are equal to each other. But this vertex angle is equals to theta, therefore the other vertex angle must be also equal to theta in size. And here we have, if you focus on the straight line edge E, and the upper side of the straight line edge E at point A, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of edge E at point A? We have this angle that is the right angle plus the missing angle. In total, the sum of those 2 angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we proved that this right triangle AD is congruent to this right triangle ADE. We proved actually that those 2 right triangles can go into each other. So why those 2 right triangles can go into each other? First of all, those 2 angles are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, side DA is a common side that belongs to both triangles, so we can write down that DA equals to itself as a common side that belongs to both triangles. And finally, those two angles are both right angles, therefore they are equal to each other. So we actually proved that those two right angles can go into each other according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles in the side that included between the two angles in one triangle are correspondingly equal to two angles in the side that included between the two angles in the second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. And here we proved that those two angles and the side that included between those two angles, that is side DA in the right triangle HDA, are correspondingly equal to those two angles and the side that included between those two angles, that is also side DA in the right triangle ADE. And therefore we proved that those two right angles can go into each other according to angle side angle rule. And from the fact that those two right angles can go into each other, we will derive that side DE in the right triangle ADE is equal to side DH in the right triangle ADH. Because again, we will derive that DE equals to DH. But D equals to 12 units according to what is given as the equation. So we can write here that D equals to 12. And from this equation, 12 equals to D equals to DH. We will derive that DH also equals to 12 units in its length. So this is side DH that is equal to 12 units in its length. Likewise, from the fact that those two right angles can go into each other, we will derive that side AE is in the right triangle AED is equal to side AH in the right triangle ADH. And again, we derive that AE equals to AH according to the sum rule that corresponding sides that can go in triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say AE and AH, must be also equal to each other. But what is the definition of AE? Side AE is the radius of the quarter circle. We define the radius of the quarter circle as R. So here AE equals to R according to our definition, and from this equation R equals to AE equals to AH, we will derive that AH also, that R equals to AE equals to AH, we derive that AH also equals to R. Here we derive that AH also equals to R. Here AH equals to R. Okay, in the next step we join points G and D together by straight line, and we join points G and A together by straight line. By doing this construction, we can get here triangle AHGE, and we have here, this is point A. Point A is defined as the circumcenter of triangle EGH. Point A is the circumcenter of triangle EGH. Why? Because of the fact that point A is located in the same distance from the three vertices of triangle EGH, and the three vertices of triangle EGH are E, G, and H. Here, the distance between A and the vertex H is R. The distance between point A and the vertex E is also R. And finally, the distance between point A and the vertex C is also R. Why? Because point A is the center of the quarter circle, point G is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is equals to R. So the distance between A and G is also R. And therefore, point A is the circumcenter of triangle HGE. And in addition, because of the fact that point A is the circumcenter of triangle HGE, point A is also the center of the circle that blocks triangle HGE. Okay, so we have, and we know that the circle that blocks triangle HGE must pass for its three vertices that are G, H, E. So we have a circle that must pass from point G, H, and E, and its center here is at point A. What is the radius of the center? What is the radius of the circle that blocks triangle GE edge? The radius of the circle, the definition of radius, it starts from the center of the circle, that is to say from point A, and ends at point E, that is a point on the circle itself. Why? Because we know that the circle that blocks triangle GHE must pass from point E, that is the vertex of triangle GHE. So, and we already found out that AE equals to R. So in conclusion, we know that we have here a circle that blocks triangle edge GE. Its center is at point A, and its radius is R from one side. But from the other side, if we complete this quarter circle AFE to a circle, we get a circle with radius R, the same radius of the circle that blocks triangle edge GE, and with the center of A. So we have two circles with the same radii, that is R, and the same center that is located at point A. And therefore, the two circles are not two circles, but one circle. Why? Because they have the same center and the same radii. Therefore, it is one circle. And for that reason, we can conclude that the circle that will be created by completing this quarter circle to a circle, this circle is also blocks triangle edge GE. It is the same circle. And because of the fact that this circle blocks triangle edge GE, it must pass through point H. Okay? So point H is located, is a point on the circle itself. And point E is also the point on the circle itself. So edge AE, what is the size of angle edge AE? The size of angle edge AE is 180 degrees. Any angle that its size is 180 degrees is defined as a straight line. So edge AE is a straight line, because this angle equals to 180 degrees, but it is a straight line that touches the circle at 2 points, edge and E. Any straight line that touches the circle at 2 points is defined as a chord. So edge AE is a chord, but it is a chord that passes through point A, that is the center of the circle. And any chord that passes through the center of the circle must be the diameter of the circle. Therefore, edge AE is the diameter of the circle. Or we can say also that edge E is the diameter of the circle. So edge E is the diameter of the circle, and we have peripheral angle edge GE that is subtended on edge E, that is the diameter of the circle. And any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees. And therefore this peripheral angle edge GE must be equal to 90 degrees in its size. Okay, so here we have quadrilateral GDAE. In this quadrilateral GDAE, those two angles, those two opposite angles, they are both right angles, and the sum of two right angles is of course 180 degrees. And we know that any quadrilateral that its sum of two opposite angles is equal to 180 degrees is a cyclic quadrilateral. And therefore, this quadrilateral GDAE is a cyclic quadrilateral. That is to say, we can block this quadrilateral GDAE by a circle. So, we actually proved actually here we blocked this quadrilateral GDAE by the red circle, and here we can implement rule 12. According to rule 12, rule 12 is true in any circle. So if we have a circle, inside this circle we have quadrilateral BA, the extended quadrilateral BA touches the extended point P, and the extended chord BA touches point P, and the extended chord DC also touches point P. So in this drawing, the following equation will be true. that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule 12 in our drawing. Why? Because in our drawing we have the common external point H. We will relate to this red circle. Inside this red circle we have the extended chord AE touches point H, and we have the extended chord GD also touches point H. Therefore, all the requirements of rule 12 are satisfied, and therefore we can implement here rule 12. According to rule 12, the following equation will be true: that edge D times edge G equals to edge A times edge E. Again, edge D times edge G equals to edge A times edge E. Repeat again. According to rule 12, the following equation is true: that edge D times edge G equals to edge A times edge E. Edge D is 12 times edge G. Edge G equals to 12 plus x, because DG is x and edge A is 12. In total, edge G equals to 12 plus x. So here, edge D is 12, edge G is 12 plus x. And it is equal to edge A. Edge A is R times edge E. Edge E is the diameter of the circle. That is, of course, equals to 2R. Again, edge A is R and edge E is 2R. In conclusion, we can find out that according to equation 1, 12 times 12 plus x equals to R times 2R. Here we divided this equation 1 by 2, and finally found out that 12 over 2 is 6. So in this side of the equation we have 6 times 12 plus x equals to, here we have 2R squared, where 2 is R squared. So 6 times 12 plus x equals to R squared according to equation 1. We divided this equation 1 by 6, and finally found out that 12 plus x equals to R squared over 6. Here we subtracted 12 from this equation 1, and finally found out that x equals to R squared over 6 minus 12. So according to equation 1, x equals to R squared over 6 minus 12. X is the variable that we are looking for in this question. In the next step, I copied this right triangle ADE in a new page and implemented the Pythagoras theorem in this right triangle ADE. This is the right triangle ADE that I copied from the original drawing. In this, we defined one side of this square as y, and therefore all the four sides of this square must be equal to y. AD is one side of square ABCD, that is equal to y. DE equals to 12 units in itself, according to what is given as the question. AE, we already found out that AE equals to R, it is the radius of the circle and the radius of the quarter circle. So we implemented here the Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ADE, DE squared equals to AD squared plus AE squared. DE is 12, therefore DE squared is 12 squared, that is 144, and it is equal to AD squared. AD is y, therefore AD squared is y squared plus AE squared. AE is R, therefore AE squared is R squared. So in conclusion, according to equation 2, we found out that 144 equals to y squared plus R squared. In the next step, we joined points A and C together by a straight line. By joining points A and C, we created the right triangle ABC. So I copied this right triangle ABC in a new page and we implemented the Pythagoras theorem in this right triangle ABC. This is the right triangle ABC that I copied from the original drawing. What is the definition of line segment AC? Line segment AC starts from the center of the circle and ends at point on the circle itself. This is exactly the definition of a radius. Therefore, AC equals to R. AC, that is also the hypotenuse, is equals to R. AD is one side of the square ABCD, that is Y, and CD is also one side of square ABCD, that is also Y, according to our definition. So in this right triangle ABC, AC squared equals to AB squared plus BC squared. AC is R, therefore AC squared is R squared, and this equals to AB squared. AB is Y, therefore AB squared is Y squared, plus BC squared. BC is also Y, therefore BC squared is Y squared. So in conclusion, we found out that according to equation 3, y squared equals to r squared plus r squared, that is 2r squared. So according to equation 3, r squared equals to 2y squared. We divided this equation 3 by 2, and finally found out that y squared equals to r squared over 2. This is according to equation 3, but according to equation 2, we already found out that y squared plus r squared equals to 144. Now we can substitute y squared in this equation 2, by r squared over 2 from equation 3. We did it and found out that according to equation 2, y squared is r squared over 2, plus r squared equals to 144. Here we multiplied r squared by 2 and then we divided it by 2 in order to a common factor with r squared over 2. So in the numerator we will have in total r squared plus 2r squared divided by 2. And it is equal to 144. Here we multiply this equation 2 by 2. And so in the numerator here we have r squared plus r squared, that is 3r squared. And 2 times 144 is 288. So according to equation 2, we found out that 3r squared equals to 288. Here we divided this equation 2 by 3. And finally found out that r squared equals to 288 over 3, that is 96. So we found out that r squared equals to, according to equation 2, r squared equals to 96. But according to equation 1, we have only found out that x equals to r squared over 6 minus 12. Now we can substitute r squared. We can substitute r squared in this equation 1 by 96 from equation 2. We did it and found out actually that x equals to r squared, that is 96 over 6 minus 12. 96 over 6 is 16 and 16 minus 12 is 4. So we found out that the length of this line segment DD that is equal to x is equal to 4 units. Again, the length of line segment DG that is equal to x is equal to 4 units. Okay, thank you very much.